Hello viewers, today we'll talk about event-driven architecture. So let's get started. So before getting into event-driven architecture, let's understand first what is software architecture. So architecture serves as a blueprint for a system. It provides an abstraction to manage the system complexity and establish a communication and coordination mechanism among components. It defines a structured solution to meet all the technical and operational requirements while optimizing the common quality attributes like performance and security. These architectural decisions include selection of structural elements and their interfaces by which the system is composed, behavior as specified in collaboration among those elements, composition of these structural and behavioral elements into large subsystems, and architectural decision aligning with the business objectives. Now let's see what is event-driven architecture. An event-driven architecture consists of event producer that generates a stream of events and event consumer that listens for the events. The event-driven architecture helps to manage this by building a central unit that accepts all the data and then delegates it to the separate module that handle the particular type. This handoff is set to generate an event and is delegated to the code assigned to that type. Some of the suitable use cases for event-driven architecture is asynchronous system with synchronous data flow, IoT application, healthcare, and online banking. You can see in this diagram, in the event-driven architecture, we will have the multiple event producers and we'll have the event consumers. So source will be the event producer and destination will be the event consumers. Event-driven architecture is design model that connects distributed software system and allows for efficient communication. Event-driven architecture makes it possible to exchange information in real time or near real time. It is common in designing apps that rely on microservices when every service runs its own process. Publish subscribe is a flexible messaging pattern that allows disparate system components to interact with one another asynchronously. Here you can see we have multiple producers which produces different kinds of events, and we'll have the different kind of consumer as well which listens to one or more events. And to manage all that, we will have in the middle event manager or the broker system. An event-driven architecture can use pub-sub model, which is also called publisher-subscriber model. The messaging infrastructure keeps track of subscription. When an event is published, it sends the event to each subscriber. After an event is received, it cannot be replayed and new subscribers do not see the events. Event streaming model. Events are written to a log. Events are strictly ordered within a partition and durable. Clients don't subscribe to this stream. Instead, a client can read from any part of the stream. The client is responsible for advancing its position in the stream. That means a client can join at any time and can replay events. In this diagram, you can see we have producers such as IoT events, or we have the e-commerce application, or some CRM tool, or SAP, or ERP, and we have the multiple consumers as well, which can be REST API, IoT, or Salesforce, or SAP, or any other consumer we can have. One consumer can listen to more than one producer as well. And in the middle at the transport layer, we'll have the broker, which can be queue or topic or message exchange, etc. So what is event? An event is a state change or an update within the system that triggers the action of other system. It can be anything from transaction and sensor input to a mouse click and photo uploads, etc. Event may vary in complexity and size and originate from both internal and external sources. So in this diagram, you can see we have multiple producers. So this is an example of e-commerce application where we'll have a user who want to place a new order, generates a new order event. Then from a mobile app, a customer submits a question about the availability of an item through the app. This is another event. And for the point of sale, a customer returns an item in person at the store. So we have the different kinds of events which generated, and each of these item is intended for different recipient. So for new order, maybe a warehouse management DB is the consumer, and for mobile app, finance system is the one which is consuming that new order, and customer relationship manager is another consumer which can listen to the events generated by the producer. And at the middle, we'll have the broker or some system which will do the filtering and routing of the events. So when should we use this architecture? We should use this architecture for multiple use cases. Multiple subsystems must process the same events. If we have the requirement of real-time processing with a minimum time lag, or if they have the requirement of complex event processing such as pattern matching or aggregation over time windows, or if we have the requirement of high volume and high velocity of data management such as IoT. So event-based architecture usually comprises of three core components: event producer, event manager, and event consumers. Event producer is the one that generates or detects events and transmits them to event managers. Event manager that acts as a middleware and are responsible for asynchronous filtering, processing, and routing of received events, and event consumers that receive events and act on them. So we'll have this source, the event data. After that, the publisher publishes the events and subscribers subscribe to those events. Now the subscriber can be a system, an application, an API, it can be anything. So what are the best principles of event-driven architecture? So first is the scalability. Event-driven architecture allows for great horizontal scalability, as one event may trigger responses from multiple subsystems with different needs and providing different results. Loose coupling. Producers and consumers are unaware of each other. There is an intermediary that receives events, processes them, and sends them to the system interested in specific events. This allows for loose coupling of services and facilitates their modifying, testing, and deployments. And unlike point-to-point system integration, components can be easily added or removed from a system. Next principle of event-driven architecture is asynchronous events. Event notifications are broadcast asynchronously, meaning events are published as they happen. A service can consume or process a published events later if it is unavailable and it does not affect or block producing events. Next principle is fault tolerance. Owning two systems being loosely coupled, the failure of one won't make any difference to the working of other systems. Now what are the benefits of this architecture? First is producers and consumers are decoupled. No point-to-point integration. It is easy to add new customer to the system. Next benefit is consumers can respond to the events immediately as they arrive. Next benefit is it is highly scalable and distributed. And at last, the system can have independent views of the event stream. Now there are some challenges as well with event-driven architecture. First is the guaranteed delivery. In some systems, especially in IoT scenarios, it is crucial to guarantee that events are delivered. Next challenge is processing events in order to exactly once. Each consumer type typically runs in multiple instances for resiliency and scalability. This can create a challenge if the events must be processed in order within a consumer type, or if the processing logic is not as important. Now what are the different tools that we use in this event-driven architecture? We can use ActiveMQ. It is a flexible open source message broker presented by Apache Software Foundation. It provides the functionality of the PubSub messaging through topics between multiple producers and consumers. ActiveMQ is relatively easy to deploy and complex structure. The system shows high throughput and great reliability. Next tool that we can use is Redis. Redis is an open source in-memory data store which is used as a message broker and database. Redis is also a popular choice for PubSub application, enhancing processing millions of requests. Next tool which we can use is Apache Kafka. It is the heavyweight in the world of distributed data streaming, the open source platform which is used for publishing, storing, and processing and getting subscriber to the stream of events in real time. Kafka provides its PubSub functionality in a highly scalable, fault-tolerant, and secure fashion, allowing for handling trillions of events a day. Besides, it can be deployed on-premise and in the cloud. Next tool is the Pulsar. It is another Apache family system for distributing publish subscribe messaging. Initially designed as a message queuing system, Pulsar was added event streaming functionality in the recent release. It is highly scalable, and the system isolates producing and consuming operation and allows for flexible messaging model. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.